Hello students, myself Gurcharan Singh Makhija, and on behalf of Narayana Academy, we are discussing chemistry paper January 29th shift 2024 means examination. And yes, this paper is memory based paper, so there might be certain change in the options given, in the questions given, because it is just memory based questions which are given by the students who have attempted that particular slot of examination. So we will discuss the JEE mains January 29th shift 1 paper right now. Question number 1 for this examination is, which of the following pair will be formed by the decomposition of KMNO4? It is again an NCERT based question. Now we know that KMNO4 on heating dissociates to K2MNO4 plus MnO2 plus oxygen gas. So it is also one of the method to produce oxygen gas from KMnO4. So the correct option should be option number 2. Is a very simple question, memory based question given in D block elements. So if we have read the properties of KMnO4, every student can easily answer that. So we'll move to problem number 2. This is a problem number 2. Here we have a cyclohexene and we are reacting cyclohexene with chlorine gas. Now it is in the presence of photon, that is H nu, and presence of CCl4. Right. Now whenever we are using photon, the reaction mechanism is free radical mechanism where the chlorine will undergo free radical substitution. Here I have a cyclohexene in the presence of chlorine. In the presence of H nu, first we know that it results in the formation of most stable free radical in the reaction mechanism, and this free radical will be colliding with the chlorine molecule, results in the allylic substitution of halogen, that is chlorine, on the cyclohexene. This is a standard example of free radical substitution. And yes, one more thing, when you use a non-polar or organic solvent the very same way, right, the cyclohexene, and when you use chlorine in the presence of an organic solvent like CCl4, CS2, then anti-addition of halogen takes place whereby one chlorine will be towards you, other chlorine will be away from you, and vice versa, the above chlorine will be away from you and below chlorine will be towards you, right? So in the presence of in the presence of organic solvent, there is normal addition of chlorine takes place and is anti-addition, right? So the correct option should be here option number 2. I guess all the student understood this thing. And yeah, one more time, they can ask you that what is the relationship between these two products. So these two products are actually enantiomers of each other. So sometimes in JEE mains, they can ask you this. Whenever they are adding chlorine cyclohexene, what is the relationship between the product formed in this reaction? Right? Hope you understood. We'll move to the next question. That is question number 3. Again, this is memory based paper. So the options and the questions might be changed, but you will get the idea that what kind of questions JEE mains is asking. Right? Any which ways, this is a very standard question, right? Here you have a benzene molecule. In that benzene molecule, we have alkene over there and an ether, right? And I'm adding concentrated HBr in excess. Concentrated HBr, right? Now we know that double bonds will undergo electrophilic addition reactions. and here we'll have substitution reaction, nucleophilic substitution reaction, right? So according to this, by electrophilic addition reaction, first H plus will attack on this molecule and results in the formation of stable carbocation. On that stable carbocation, the nucleophile will attack and addition reaction takes place. Is a Markovnikov addition. This product will form, and here this will get activated into a good living group where Br minus will undergo an SN2 reaction. So this molecule will break, the bond will break from in this direction. So the resulting answer for this question should be so the correct option of this small is this reaction should be your option number 3. Hope you understood that double bond will undergo electrophilic addition reactions, and yeah, ether will undergo substitution reaction. Depends on the kind of ether, it can undergo SN2 as well as SN1 reaction. So we'll move to another question. Which of the following coordination compound has bridging carbonyl ligands? Okay. Now, obviously, the very standard question, memory-based questions came from your beloved chapter coordination chemistry in and from NCERT is a direct question, carbonyl compound, homoleptic carbonyl compounds. So here I have CO, cobalt. This cobalt is having the COCO8, 3 carbon monoxide molecules which are acting as normal ligands where they are donating its lone pair to the central atom this way. Here also and yeah, one of the carbonyl molecule form bridge ligands and there contain one more metal bond, right? Now this is the actual structure of CO2 CO8 where I have a metal linkage also as well as I have carbonyl molecule which is forming a bridge structure between two cobalt. And remember one more thing, this C double bond O has bond order nearly 3 and this C double bond O is having bond order nearly 2, so their bond lengths are entirely different. This is one of the thing which I am telling you in this particular question which will help you in further examination. So we'll move ahead to the next question. Now question number 5, energy difference between the actual structure of the compound and the most stable resonating structure having the least energy is called. See, it is a very standard definition. Whenever you have multiple canonical structure and a hybrid structure, and the most stable canonical structure and the hybrid structure, the energy difference between them, there is a most stable canonical structure. Like I have psych, I have normal butadiene. If I am drawing the canonical structure of this molecule, so I'll be having these two canonical structure. Actual structure will be the hybrid of this structure. This is the hybrid structure. This is most stable canonical structure. The energy difference between these two structure is known as resonance energy. Resonance energy. Hope you understood that. Right? It's a very straightforward question from thermodynamics. Right? Now, what is the effect that occurs between the lone pair and pi bond? I have a lone pair, then I have a sigma bond, and then I have a pi bond. You know that the in this molecule is a phenomena known as resonance, in which the oxygen atom, which has a complete octet, will donate a pair of electron in the vacant antibonding molecular orbital of C double bond C. Right. So this phenomena is known as resonance. The correct option is 3. Hope you understood this, right? So we'll move to next question. That is question number 7. Which of the following statement is incorrect? Again, from thermodynamics, the straightforward question, NCRT based. Now, delta G of system is 0 for a reversible process. This is reversible slash equilibrium. And delta G of system should be lesser than 0 for all spontaneous processes. So delta G of system is greater than 0 for the reaction which are non-spontaneous. Right. So the correct option, see, we have to find out which statement is incorrect. Obviously, delta G is greater than 0 for spontaneous process is not correct. So answer is supposed to be 3. Right. So shall we move ahead? Now in question number 8, alkaline KMnO4 oxidizes iodide to a particular product A. Determine the oxidation state of iodine in a compound A. Now listen, this is very genuine question, which is very standard question. Whenever you have KMnO4, you know that KMnO4 is actually an oxidizing agent which will oxidize I minus to iodine and Mn2 plus. This happen in acidic medium. In alkaline medium, on the contrary, I minus will be converted into IO3 minus, and I'll be getting MnO2. Right. So the oxidation number here is -1 and oxidation number here is +5. So there's a net change of 6 electrons from. Now, many students ask me how to remember this thing. See, I know that, or we know that iodine is the product which is generally formed by oxidation of I minus, and we know that iodine in basic medium undergo a disproportionation reaction to form I minus and IO3 minus, whereby I minus is your reactant from where you started, and eventually I2 is converted into IO3 minus. So I guess this trick will help you to remember in the future that iodine in the presence of alkaline KMnO4, that is an alkaline medium, is actually converted to IO3 minus, right? We'll move to, so the answer for this thing is option number 3. We'll move to next question. Find product P of the following reaction. They have given a styrene molecule. There they are adding electrophilic addition reaction of water. water is being added inside double bond, and they're doing oxidation with the help of CrO3 and H plus, and after that they are using Fulvic reaction to reduce that double bond. Very simple question, very is NCRT based question again. So till now none of the question is being asked outside the syllabus, right, in this paper. So you have C double bond C. I have like C double bond C here, benzene, and we are doing electrophilic addition reaction. So here H plus will attack on this carbon, pi electron will shift, whereby in that resulting carbocation, this water molecule, which is a nucleophile, that undergoing addition reaction, and it results in the formation of O positive H, and you know that H plus will leave, O positive will gain electron towards itself. So the final product or the first part will be a benzene molecule, NOH. This is a secondary alcohol, and we very well know that secondary alcohol will get oxidized by an oxidizing agent to form ketone. Ketone. And then we have Wolff-Kishner reaction. In the Wolff-Kishner reaction, you're using hydrazine in the presence of KOH, basic medium, and we know that this C double bond O eventually will be reduced to alkane. So the product will be this. So answer is 3. And a student who has read NCRT thoroughly can easily solve this question. Everything is from NCRT right now, right? So till now, every question which we have discussed was from NCRT. Again, this is memory based question paper, so question might be different in the actual JEE mains paper, right? Now in option 10, a container contains 1 gram of hydrogen and 1 gram of oxygen gas, where the ratio of the partial pressure of hydrogen to the oxygen. They never see, when nothing is mentioned, take temperature, volume constant, right? So we know that according to ideal gas equation, PV is equal to nRT. So partial pressure of hydrogen should be directly proportional to number of moles of hydrogen, and partial pressure of oxygen is directly proportional to number of moles of oxygen, right? Now student might say it's from gaseous state, which is a deleted portion, but this is very general formula and every student can easily do it, right? Now here partial pressure of hydrogen to the partial pressure of oxygen should be equal to number of moles of hydrogen, that is 1 gram divided by molecular weight. What is the molecular weight of hydrogen? 2 grams, and into number of moles of oxygen is 1 gram divided by what is the molecular weight of oxygen? 32. So partial pressure of hydrogen to the partial pressure of oxygen comes out to be 16. So the actual answer should be answer 1. Yeah, it's a very simple question. No need to read the entire gaseous state. Genuine question in stoichiometry chapter, you would have used PV is equal to nRT, pressure number of moles relationship. You can easily do it, right? So I guess a student will got the clarity in this question. We'll move to question number 11. Now it's the matching question. Now again, this questions came from your ores and metallurgy. Okay. Now dolomite is the only one option which generally student doesn't know, but every other student will know all the things because it's very general compounds, right? Now fluorspar. What is fluorspar? Your fluorspar is calcium fluoride. That is option number Q, right? Cryolite, from childhood only, you know what is cryolite, right? That is Na3 AlF6. Aluminium has 6 coordination number in that, right? Generally with chlorine it form 4 coordination number, tetrahedral geometry. With fluorine, yeah, fluorine is small, so 6 fluorine can accommodate both around Al3 plus. Bauxite, Bauxite, it is your Al2O3 dot XH2O, right? That is 2H2, which is given to us, right? And dolomite. Dolomite is MgCO3 dot CaCO3. So this is your S, bauxite, this is your P, and this is your R. So 1Q, BS, CP, and DR. Answer should be 2. Simple. We'll move ahead now. Yeah, certain student might argue that this question is out of the portion, but yeah, uh, it is not tough. Well-known compounds are there. A student can find problem only in dolomite. Apart from that, everything is fine. Which of the following element is R confirmed by the appearance of blood red color with FeCl3 in Lazan's test? Again, it is very simple question, came from NCRT, direct question. Now, blood red color, every one of us knows that when Fe3 plus reacts with thiocyanate, it results in the formation of a complex FeSCN whole 2 plus, which has blood red color, and we know that we require sulfur, carbon, nitrogen, all the 3 elements, right, in order to produce an ionic compound, that is thiocyanate. I'll just give a brief about that. Suppose an organic compound contains sulfur, carbon, and nitrogen. So sodium fused with the organic compound, and that organic compound contain all these 3 ions, and I'm adding sodium in less amount, then it results in the formation of NaSCN, right? And if suppose you are using sodium in excess, then it results in the formation of Na2S and NaCN. Nitrogen will always be associated with carbon, and the anion formed by that will be cyanide, SCN minus. So by this logic, every one of us knows that the organic compound should contain nitrogen as well as sulfur. The answer is 2. Simple. We'll move ahead. 13. Statement 1. Electronegativity of group 14 element decreases from silicon to lead. Listen, this question came directly from 14 group, that is P block, right? And we and Narayana told students specifically that, and we made them to remember all those trends. We have spent a lot of time in making the student understand how these trends are observed inside a particular group. So you also should know all the physical and chemical property trends in the respective groups, and it is directly came from NCRT, memory based question, right? Yeah, with some logical understanding, like from tin to lead, the electronegativity increases because of poor shielding done by DNF orbital electron. F orbital electron plays a vital role over there, because screening or shielding effect of F orbital is very less, right? Because of that, lead will have more electronegativity as compared to tin. Then group 14 elements has metalloids and non-metals that every one of us knows, right? So yeah, statement 1 is false, because from tin to lead electronegativity increases. So statement 2 is true. And you know that metallic character increases down the group. Getting it? Sure. So carbon being a non-metal, on going down the group, it become metalloids, and then it'll have lead, essentially a metal, right? So the answer is supposed to be statement 1 is incorrect, statement 2 is correct, answer is 4. Hope you understood this particular question, right? Memory based question. Every student should know the general chemical and physical behavior or properties or trends in the respective groups, right? It's very important thing. Hydrolysis of protein gives which type of amino acids? We know that in our body, all the amino acids are alpha amino acids, right? Whereby you have a COH group on the alpha carbon, and these are all L amino acids. That is why I'll keep this NH2 on the left hand side. You have one hydrogen, and there are 20 different groups over there. Uh, L and D amino acid is not valid for glycine because glycine is optically inactive. Apart from that, 20 amino acid will be optically active, right? So the carbon where a functional group is attached is known as alpha carbon, and on the alpha carbon you do have an amino group. That is why it is known as alpha amino acids, right? So obviously, very simple question. Answer should be 1. Getting it? Okay, we'll move ahead. Question number 15, statement 1. Ionization energy decreases in a period. Every one of us knows that on moving along a period, right? Effective nuclear charge increases. Why it increases? Increase in positive charge inside the nucleus is not overcome by or compensate by increase in shielding. So along a period, effective nuclear charge increases, ionization enthalpy increases. So the correct option for this, statement 1, definitely 100%. False. And statement 2, in a period Z dominates over scaling of it. That is 100% correct. Question came from periodic properties, and simple question, just the twist of language. Statement 1 is incorrect, but the statement 2 is correct. The answer should be 4. Shall we move ahead? I guess you understood, right? Question number 16. Consider the following reaction. We are reacting aniline in the presence of bromine and CH2, right? And they are asking intermediate. Okay? So again, whenever you are using carbon disulfide, the major substitution will be at ortho and para position, right? So here nitrogen will attack, will give the lone pair, and this orthocarbon will have a negative charge, right? Now, because of negative charge, will attack on Br2, Br plus will attack on ortho position, and Br minus will leave. So eventually, you will get, right? And now, due to resonance, we will get a positive charge on the adjacent carbon in the sigma complex formed by this. So we are getting option 2 as a correct option, right? So answer is supposed to be 2. Hope you understood this, right? We'll move ahead. 17. Now again, memory based question. All of us knows that, right? Now vitamin B12 contains cobalt. Wilkinson catalyst is a rhodium complex, right? It'll do the hydrogenation of least sterically hindered alkene. Ziegler-Natta for polymerization of alkenes have TiCl4 plus triethyl aluminium or trialkyl aluminium, or you can have TiCl3 plus dialkyl aluminium chloride. Now option D, hemoglobin, obviously iron. Um, Very important point for advance for iron in hemoglobin. It forms a square planar complex and it contains two unpaired electrons. By normal technique, you will not get it, right? Just an extra information, right? So we'll move to question number 18. K2Cr2O7 H2O2 and H2SO4 ether. Standard question from D block again. If this reaction results in the formation of CrO5, where you will get Cr double bond O and two peroxy linkages, you will have a butterfly shaped structure, and the oxidation state of chromium is +6. So answer is +1, like first one, right? So very simple question, straightforward question, memory based question, direct question came from D block. You have question number 19, right? Chlorine in the presence of OH minus in basic medium is forming Cl minus and ClO minus, right? You know that chlorine in the presence of basic medium undergo a disproportionation reaction, cold dilute basic medium, right? Now cold diluted basic medium Cl2 will undergo disproportionation to form Cl minus and ClO minus. Here, this chlorine, let's say, undergo reduction. This chlorine, let's say, undergo oxidation. First, balance the atom which is undergoing reduction and oxidation. Write down oxidation number 0, 0, minus 1, plus 1. Balance the electrons. Calculate the number of electron lost or gained. 0 to minus 2, it is gaining 2 electron per mole and is losing 2 electron per mole. So directly add the reactions. So it will become 2Cl2 gives 2Cl minus plus 2ClO minus, right? And you will get balance it, right? I'll get Cl2, it will give you Cl minus and ClO minus. Balance oxygen, add a water molecule over here, balance H plus 2H plus, balance the reaction in basic medium, add equal amount of OH minus on both the sides. Then this becomes water. Here I have already one water molecule, cancel it. So you will get a reaction here, 2 OH minus plus chlorine gives Cl minus, ClO minus and a water molecule. Now we'll see what he is asking actually. X is equal to 1, clearly Y is equal to 2, Z is equal to 1, P is equal to 1. So answer is 4. Hope you understood this particular balancing, right? So we'll move ahead. For rubidium, right? Is the following set of quantum numbers are correct for a valence electron? Lithium, sodium, potassium, rubidium, cesium. All of us knows rubidium is a part of alkali metals. And there's second period, third period, fourth period, fifth period. So no need to write down that Aubert principle, calculate what is the electron outside electron. It's better. Rubidium is fifth period element. So the valence shell is 5s1. If it is 5s1, so n value is 5. L value for s is 0. Obviously m will be 0 and your s should be plus or minus half. Now balance it, like check which option is correct over there. Option number 1. So this kind of question can be done directly, no need to write down Aubert principle, long electronic configuration. A student might do error in writing this thing, right? So any which ways, you understood. This is the end of objective questions. Now we'll go for integers, right? Now I'll just suggest the student to choose 5 integers which they can do and properly without any mistakes, so that they should not lose any marks in the JMN examination. Out of 10, 5 can be chosen easily, right? So yeah, question number 21. Calculate the molarity of a solution having density 1.5 gram per ml. Percentage weight by weight of solute is given to you as 36%, and molecular weight of solute is 36 gram per mole, right? So we'll do one thing. We have density. We can easily calculate. See, there should be one assumption to solve this question. An assumption should be made in such a way that your life should be simple. So we'll do one thing. We'll assume. So in solution, we'll assume that volume of solution is 1000 ml. That is 1 liter, right? So if we calculate the number of moles, so number of moles of volume in liter will directly give me the molarity, right? So here mass is equal to volume into density, which will be equal to 1000 ml into 1.5 gram per ml. So we'll get as 1500 grams of mass of the entire solution, right? Now he says that your solute is 36% of the entire solution. So the weight of solute should be equal to 36% of the entire solution, right? So you'll get 15 into 36 grams, right? So here, after this, you want to calculate number of moles of solute. So number of moles of solute comes out to be weight by molecular weight. It comes out to be as 15 into 36 divided by 36. So I'll get 15 moles. And 15 moles are present in 1 liter. That means molarity is 15 only. So it is the assumption which you make will make the question simple, right? We'll move ahead. Given K net for a complex reaction K1, K2 by K3, where EA1, EA2 and EA3 are given to you, right? Now listen, K1 is equal to A1 dot E minus EA1 by RT. K2 is equal to A2 into E minus EA2 by RT. K3 is equal to A3 into E minus EA3 by RT. Now what you are doing, you are multiplying K1 and K2 dividing with K3. So you will get the net equation as A1 A2 by A3 E minus, you will get EA1 plus EA2 minus EA3 by RT, and this is net EA. So very simple, net EA will be 40 plus 50 minus 60. So answer is supposed to be how much? Simple. So we'll move ahead, right? Positive Fehling solution test is given by all non-aromatic aldehydes gives positive Fehling test, right? So choose all aldehydes which are non-aromatic. So answer is supposed to be what? CH3 CHO will give, formaldehyde will give, and your cyclohexane carbaldehyde will give. So these are the molecules which will give Fehling test. Answer is supposed to be 3. And the aromatic aldehydes in which the aldehyde is directly attached to the aryl molecule, whether it can be your benzene or it can be your furan, will not perform this test. Getting it? So Fehling solution or maybe Benedict solution will not give this test, right? So we'll move ahead. In question number 24, how many of the following compounds will have one lone pair in the central atom, right? Now, ClF3, if you draw normal bonding only without drawing the actual molecule, you'll get this answer. Xenon, BRF3, one lone pair will be left, 5 electrons will form a bond with fluorine, XCF4. 2 lone pair will be left over, 4 fluorine will form a single bond with it. Ozone, oxygen central atom will form a double bond and a coordinate bond with the oxygen, I'll have one lone pair left. Again, the central atom has one lone pair. Ammonia, the standard structure. Ozone and ammonia, every student would have seen multiple times in NCRT paper, in NCRT textbooks. So they very well know the actual structure of ammonia and ozone. So there might be no difficulty in attempting this question. Very peaceful question. Every student should attempt this kind of question because it's free marks, right? So answer should be XeO3, BRF5, ozone, and ammonia, right? So these are the four molecules which will have one lone pair in the central atom, right? Answer should be 4. Shall we move ahead? 25. How many of the following species have a bond order is equal to 1 and are paramagnetic as well? Okay, they want paramagnetic, not diamagnetic. If you choose He2 2 plus is same as hydrogen, sigma 1s2 I'll get. Bond order will be 1. I don't have any unpaired electrons, so this is diamagnetic. O2 2 minus will behave like F2 only, right? Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then you'll have sigma 2pz2, pi 2px2, pi 2py2. Then you have pi star 2px2, pi star 2py2, and sigma star 2pz0. It is vacant. Check bond order. Anti-bonding, bonding get cancelled. You have 6 bonding to 4 anti-bonding. So bond order comes to be 1. But again, they are not paramagnetic. It is diamagnetic because you don't have any unpaired electron. So diamagnetic. Next, Ne2 2 plus. Again, this will behave as fluorine. The above example is the above electronic configuration is same as Ne2 2 plus. Again, bond order will be your 1, and again it is diamagnetic. Peaceful question. Fluorine. He has given the same thing, right? Fluorine we have already covered because they have the same molecular orbital configuration as fluorine. Boron. The number of electron in the boron will be 5. So sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then you have pi 2px1, pi 2py1. Now this is the species which has actually bond order 1, and yeah, it has 2 unpaired electrons, so it will be paramagnetic. So boron is paramagnetic, right? Thereby you have hydrogen. Just now we have discussed about hydrogen. The is same as He2 plus, sigma 1s2, bond order is 1, diamagnetic. Then you have O2 plus is same as fluorine. We have done bond order 1. Yeah, it is diamagnetic. So I'm getting only boron as paramagnetic and has only one bond order. So answer is 1. And that too boron, B2. Hopefully you understood this, right? We'll move ahead. How many of the following compound contain sulfur atom? Pyrrole, furan, thiophene, cysteine, tyrosine, and pyridine. Uh, okay. Pyrrole. This is our beloved pyrrole. No sulfur. Furan. I have oxygen. Everyone knows that aromatic species. Thiophene. is also known as thiofuran. Instead of oxygen, you have sulfur. So yeah, this is one of the option, right? And cysteine is an amino acid which contains sulfur, right? So you have carbon, COH, uh, NH2H, and you have carbon, and yeah, an SH linkage is there. SH bond is there. Cysteine. So it contains one sulfur. Then tyrosine. What is tyrosine? Tyrosine again an amino acid which contain a phenol molecule, right? Aromatic moiety inside an amino acid, and pyridine. Every one of us knows, right? So yeah, you'll have two molecules which will have sulfur inside them. The answer should be two. One extra information: there are only two amino acids which contain sulfur. That is cysteine and methionine, right? And methionine is the very first amino acid which a protein molecule contain, because starting codon will uh, target methionine as a precursor amino acid, right? So the extra information. So methionine, cysteine contain sulfur. These are two amino acids. Only two amino acids, right? Now question number 27. Through a ZnSO4 solution, 0.015 ampere current was passed for 15 minutes. What is the mass of zinc deposited in milligrams? Right. So it's a very simple question based on Faraday's first law of electrolysis. V is actually equal to ZIT, where Z is electrochemical equivalence, where Z is equal to E by F, where E is equal to weight by equivalent weight. Equivalent weight is equal to atomic weight by valency, that is 65.4 divided by 2 into 96500, right? It comes out to be 65.4 divided by 2 into 96500 into I is 0.015 into T, which is 15 into 60. The answer will come in grams, so I want in milligrams, so multiply that thing with 1000. So answer will come as 4.58 milligrams. So very simple question, right? We'll move ahead. Osmotic pressure at 273 Kelvin is 7 into 10 to the 5 pascals. Then what will be the value of X if its atomic osmotic pressure at 283 Kelvin is okay? So it is, see, we know that pi is actually equal to ICRT. Now, in this case, they are just changing temperature, nothing else, and we know that uh, pi is directly proportional to temperature, right? So pi 2 by pi 1 is equal to T2 by T1. Just use this, you'll get the answer. So pi 2 comes out to be T2, which is 283 Kelvin, divided by 273 Kelvin into pi 1. What is pi 1? 7 into 10 is to power 5 pascals. I want answer in, so divide by 10 is to power 4, right? So the nearest integer will be 72.56, which is approximately equal to 73, nearest integer, right? So this is a question number 28. Now question number 29, which is the last question we have in this memory based paper. Now Kp of the given reaction is, find out Kc. Now the given reaction is here 2 times NO2 gas, which is converting into N2O4 gas. Now this is a reaction which is available here. He's saying in nearest integer, right? So we know that Kp is equal to Kc RT delta N. What is delta N? Stoichiometric coefficient of products minus reactants. That is 1 minus 2. This comes out to be minus 1. So I'll get Kp is equal to Kc RT raised to power minus 1. So Kc comes out to be Kp into RT. Kp is 36 into 10 to the power minus 2 ATM inverse into 0.0821 into your temperature, which is 298 Kelvin. The temperature is not mentioned, take standard temperature. It is 25 degrees Celsius, 298 Kelvin. The answer comes out to be your 9, approximately 9. So student, this was the end of discussion of the paper. Hope you have understood each and every type of question which is asked in JEE mains, and hope this video will enlighten you, and best of luck for your examination. Thank you.